Hello. Good morning, everyone. My name is Clayton Crocker, and I'm a scientist and engineer with the Quantum Engineering Solutions team at Keysight Technologies. And today I'm excited to talk a little bit with you about how Keysight's developing solutions to help accelerate quantum innovations, both here in Japan and globally. So before I get into that, I want to talk a little bit about some of the history of Keysight and actually what's brought us to where we are today. Keysight has got over 80 years of history, kind of helping guide the development and accelerate the development of wave after wave of technological innovation. And so kind of as we find ourselves today at the kind of early stages of the quantum revolution, this is kind of what's given us the history and the context to have some of the expertise in hardware, software, as well as the expertise in guiding these technological innovations through kind of from start to finish to help position us to be a good partner in this space. Closer? Thank you. So today where that's brought us to is a point where Keysight as a company is partnering with hundreds of different research institutions, universities, and companies in the quantum space. We are also collaborating with a number of consortiums, both in the United States, here in Japan, and across the world, that have all kind of led to us developing a broad portfolio across the quantum development cycle, across the technological development cycle for the quantum industry. So to shine a little bit of more light on what I mean by that, one picture we can use for the development cycle for quantum computing is kind of what we think of here. We might start with something like some electronic design and automation tools for actually designing qubit chips. From there, work toward test and measurement solutions for characterizing and proving out the individual quantum components that you've designed. Beyond that, it's going to be super important to start putting everything together into integrated quantum systems. And that's where people are going to really need these quantum control solutions for testing and developing, not only testing and developing these quantum systems, but also iterating and improving on those, addressing some of the errors that these systems can have, which really serve as kind of a seminal challenge to the field right now. And then finally, one thing that Keysight really firmly believes is that what we say is kind of today's breakthroughs need to be tomorrow's subroutines. And so within this quantum development cycle, the last thing I'm going to talk about are some of the automation software and capabilities that Keysight can provide to help accelerate quantum innovation and help drive this development cycle more quickly. So starting with some of our tools in the EDA, or electronic design automation space, for designing qubit chips. This is a space that Keysight plays in a lot of industries, and I'm really excited to announce that we've also made strong investments in this for the quantum industry. So are now on the second generation of our Quantum Pro design software. This is a tool that lets users start by designing their actual quantum circuit, laying out the circuit itself using either components of their own design or components from our own quantum artwork library. This is actually one of the big advantages of our new Quantum Pro 2.0 update, is we've really doubled the size of this quantum artwork library, adding things like Josephson traveling wave parametric amplifiers to it that users can pull in right off the shelf to integrate into their quantum layouts. From there, you're able to kind of either use local computing resources or high-performance computing environments through the cloud to run full EM simulations on your quantum layouts, extract the quantum parameters that are relevant to you and your design, and feed those back into your quantum circuits to inform the next circle in this design process. And so this really serves as a foundational stage of your quantum development cycle. What we kind of think of as without a good EDA background, without good tools for understanding how your design decisions impact the quantum parameters that you can extract here, you're more or less flying in the dark. So this is a really important beginning to the quantum development cycle. From there, you move from the stage of strictly planning out your quantum systems to actually getting individual quantum components made, and it becomes really important to start testing those. And this is a place where Keysight's really advanced test and measurement portfolio comes in handy. Between some of our box top instruments, signal sources, amplifiers, analyzers. We're actually in almost every quantum lab in the world already today, measuring these individual components, proving out performance, and letting users understand how they're going to behave before they ever start integrating them into a full quantum system. But as the field is beginning to advance and mature, so have the needs for these test and measurement solutions. And so we've been working with some of our partners to help develop more advanced and complex solutions. So this can include things like wafer testers for accelerating this cycle by actually evaluating the performance of different quantum components while they're still on wafer, as well as cryogenic measurement systems, which can help address the really difficult problem of understanding how these components perform, not just at room temperature, but how that changes as you actually cool them down and put them inside of a cryogenic environment. Finally, once you're really understanding how all of the different quantum components in your system works, a full quantum control solution to actually put together your system into an integrated quantum system, an integrated quantum computer, and control that quantum computer really becomes an indispensable tool. And here's where Keysight's quantum control system, or QCS, comes into play. It provides a full stack solution for the control of these quantum computers, and kind of thinking throughout the whole stack, maybe vertically, as well as the development cycle more horizontally, really adds a whole nother dimension to the different ways that you can collaborate and partner with Keysight in this space. And the last thing I mentioned earlier, in terms of the development cycle, has to do with test and automation software. So, as we mentioned before, as we're all developing this field, moving toward more maturity, we find that things that used to require real manual effort and very deliberate work end up needing to be automated. And in support of this, Keysight has a number of test automation software platforms, and the one that I'm excited to share some details about today is our kind of newly released experiment automation workflow. This is a platform, a tool that allows users to run quantum experiments, to fit the data from those experiments, extract parameters from that data, and use that to update their full calibration set, and then run subsequent experiments now with that fully extracted data. And so these are the kinds of tools that we provide to help move through the development cycle and really accelerate all stages of the quantum research. I mentioned before this kind of key other dimension, though, of our involvement in this quantum space is not just the development cycle, but also as you're actually using a quantum computer, as you're developing your own quantum system, being able to execute across the entire quantum computing stack. And this is another key way that Keysight's able to help accelerate your quantum innovation. So one thing we really believe in this regard is that kind of the key to having a tall stack, a powerful stack, is going to be having a solid foundation. This is one place that we've been able to leverage. Our 80-plus years of experience has given us both the expertise and the infrastructure to build our own custom ASIC for producing and modulating the microwave signals that are needed for controlling quantum computers. This really serves as the foundation for all of the components in our QCS, in our quantum control system. And it's kind of what lets us have really unparalleled signal quality and noise performance in our system. Today, though, having a full quantum control system requires a lot more than just solid noise performance. You really need to be able to put this together in a way that is synchronized, in a way that operates as a single large quantum system. And so this is why we've invested heavily in both software, hardware, and FPGA gateware that lets us scale these systems from the small laboratory style systems to kind of kilo-qubit scale operations without sacrificing performance. From there, the next really critical stage is going to be thinking about, okay, not just does the hardware work, but can a user actually run it? Are we able to translate something that a quantum physicist or a user at another level has in their mind into something that can actually be run on hardware? So this is where the quantum control software ends up being extremely important. This is a really diverse field still. There are people who are thinking about running new integration filters or waveform shapes to improve single qubit gates on just a small system. At the same time, there are a lot of people who are trying to write the next greatest and longest algorithm that they can execute. So having a quantum control software that allows users to program at both levels of waveforms or quantum circuits and algorithms, we think is really critical. It's our intent with the quantum control software to provide both of those and to let people kind of mix and match for whatever way of organizing this makes sense to them. Beyond just actually creating some kind of an experiment or an algorithm to run, though, really a seminal challenge working our way up the stack is going to be dealing with the decoherence or the errors that your system accumulates. And so this is why kind of at the higher levels of the stack, Keysight's been really interested in developing error mitigation software through our TrueQ platform. Today, this provides a whole suite of tools from kind of leading error diagnostics tools to find out where the errors actually are in your quantum computer, to things that actually let you mitigate those errors, so error mitigation tools. And tomorrow, this is what we'll use these same technologies forward for the fault tolerant and error correction codes of the future. So at the very top of our stack then, I'm excited to talk about some of our developments in a kind of a full cloud solution at the very top of this stack. This is what lets us work with our partners to both provide tools for them to submit jobs remotely onto the quantum control solution with tight integration through the stack to actually execute these algorithms, to perform their quantum measurements, to run the system at whatever level makes sense to them, both for us to collaborate with our partners and for them to collaborate with others in the community, maybe their own customers, provide access to that through the cloud. It's kind of in recognition of a lot of the ways that Keysight is providing solutions, both across this quantum development cycle and throughout this control stack. I'm excited to talk about some of a major partnership that we have recently been able to go public with. It's actually through our Memorandum of Understanding with AIST and GQuat here in Japan. So this is just one of the many ways that we are kind of able to expand partnerships in this field, and we're really excited to be working with them moving forward and helping to accelerate their innovation here in Japan as well as abroad. And so the last thing I'd like to maybe end with is just a kind of a repetition of what I know a lot of other folks have said here today, is that quantum computing is it's going to be a journey. This is a multi-decade process, and it's too big for any one company to handle on their own. And so as you think about partners that can help work with you in this space, we encourage you to think about some of the ways that Keysight is providing solutions across the development cycle and across the computational stack. Thank you.
Thank you very much. So we have a couple of questions. And before we go into that, just a reminder that I think the QR code will come up in a second, but for the individual sessions taking place in this room, unfortunately not for the track in the other room, but at least for the sessions in this room, we will be taking questions via Slido. So if you haven't done so already, please feel free to scan the QR code and type in your questions using your smartphones. So we have a couple of questions for Clayton. We have, first of all, the question, how does qubit control scale on power consumption versus qubit count?
That's a great question. So the question was, how does power consumption scale as the number of qubits increases? This is actually a really common question that we see, is not just power consumption, but size, weight, costs, kind of the full C-swap question. With our current generation solutions, we see really a marked improvement in this over the previous generation. But kind of how we think about that is every generation, you come up with a new platform for the technology, and from there it ends up scaling more or less linearly with the actual number of qubits. So I think this is something that we as a field, not just at Keysight, but working in collaboration with all of you, will continue to find ways to to help that scale in a much nicer way. And at the same time, we'll continue to push the limits of the technology that we have today.
Sounds good, thank you. We have a couple more. First, what's the largest quantum system size you imagine QCS being able to realistically control, and at what size do we need new control types?
It's a great question. So the Keysight quantum control system that we've shown here today is really designed to control up to kiloqubit scale solutions. So order 1,000, thousands, maybe pluralizing that. As we think about going to tens of thousands of qubits, I think that's the point where we need to start thinking about additional qubit control platforms, additional paradigms for that, which will involve both work from our side, miniaturizing and scaling up these systems, as well as work kind of as a whole community of finding ways that we can multiplex signals, that we can demultiplex signals down at the cryogenic level. These are all things that we're also investigating and working with partners on as well.
Thank you. And finally, does Keysight develop their own software packages, or is it compatible with common packages like Qiskit or Q2B?
The answer is yes to both. Keysight is developing our own software packages. The TrueQ software that I mentioned before that provides these tools for error mitigation and detection all has its own way of expressing quantum algorithms. But as we've seen, and one thing I think is a real positive part of the community in general, is there are great tools for converting between packages. There isn't a sense that you have to find one partner and work only with them, and so there are great ways to convert across different ways of expressing quantum circuits.